Hello everyone, welcome back to this Unity tutorial series on how to create a roguelike like Vampire Survivors. Picking up from where we last concluded, this part will aim to elevate our game manager and user interface to new heights. We'll delve into enriching the player interactions with features such as the upgrade selections during level ups and a dynamic health bar display. These enhancements promise to amplify the gaming experience, making the game more immersive and engaging. And by the end of this part, you should have something like this, which is a stopwatch to track the player's progress of the stage, a game state, which is the level up, the upgrade options you can see that we can select from, and we will make some improvements to these upgrades as well. And we'll have some additional UI such as the player level display and the player health bar. And without further ado, let's begin. We'll first begin with the stopwatch feature. In Vampire Survivors, the main objective is to endure until the stage is successfully cleared. The player's progression is monitored via a stopwatch located at the top of the screen. To successfully complete the stage, the players must just persist until the stopwatch reaches the predetermined time limit for the stage. And upon reaching this time limit, a Reaper will spawn every minute to confront the player and end their run. So let's integrate this feature into our game, thus providing the players with a concrete goal to strive for. To start, we'll access our game manager script and establish the required variables. First up will be time limit, which is a public float variable to hold the time limit in seconds. Afterwards will be stopwatch time, which is a float variable to track the elapsed time since the stopwatch has started. And third will be a stopwatch display, which is a public text variable to store the object responsible for displaying the time. Now, let's proceed with creating a method called update stopwatch to just handle the code responsible for updating the stopwatch. Within this method, we'll simply increment the stopwatch time by the amount of time that has passed since the last frame, which can be just achieved using time.delta time. Next, we need to call this method within update, specifically under the gameplay case block. By doing this, we can just ensure that the stopwatch only runs during the gameplay state. When the game state changes, the stopwatch will stop running, providing the desired behavior. Some of you may be wondering why we didn't create a bool variable to serve as a switch for controlling the stopwatch's activation. The reason behind this is that we don't really need a separate bool variable since the running status of the stopwatch is already being tracked through the current state. In this case, the stopwatch starts when the game state is set to gameplay and it stops when the game state is set to game over. Therefore, the stopwatch can naturally turn on and off based on the active state without the need for an additional bool variable, because if the state is not active, the stopwatch will just automatically disable itself. Now, let's test the functionality we've implemented. In the Unity editor, let's enter the debug mode by accessing the inspector. And once in game, select the game manager object and observe the inspector. You should see the stopwatch time variable steadily increasing. If you pause the game, the value should freeze, and upon resuming, it should resume counting. Additionally, when your character dies, the stopwatch time value should also freeze due to the game state transitioning to game over. Moving forward, let's incorporate the functionality to end the player's run once the time limit is reached. This is a straightforward task. In the update stopwatch method, we'll check if the stopwatch time value is equal to or exceeds the time limit. If it does, we'll simply call the game over method to handle the necessary actions. Now, for those of you wondering about the Reaper that I was just talking about, for now we won't delve into it, instead we'll just simply end the game. Before we return to the Unity editor, let's first address the UI display for the stopwatch, which will allow us to see it in game. Instead of simply showing the increasing float value of stopwatch time, we'll format it to follow the minutes-seconds convention. So this convention will enhance the visual appeal and improve readability for players. Let's proceed with the following steps. First, let's create a method called updateStopwatchDisplay. This method, as its name suggests, will be responsible for just updating the text object that displays the current time on the screen. Create two local variables of type int named minutes and seconds. Now, to calculate the elapsed time in minutes and seconds, we'll use the mathf.floor_to_int method. So this method just rounds down the stopwatch time variable to the nearest integer and converts it to an integer. Afterwards, we'll then utilize the string.format method to present the UI display in terms of minutes and seconds. Lastly, call the updateStopwatchDisplay method within the updateStopwatch method. These steps will ensure that the stopwatch display is being updated accordingly. If you're unsure as to how this works, allow me to explain the process. So firstly, the variable minutes is obtained by dividing the stopwatch time by 60 since there are 60 seconds in a minute. Afterwards, the modulus operator is utilized to find the remainder after the division. In this case, stopwatch time modulus 60 calculates the remainder when the stopwatch time is divided by 60, and the resulting value is assigned to the variable seconds. Afterwards, the mathf.floor_to_int function is applied to round the result down to the nearest integer, ensuring that the stopwatch display does not show a higher value than the actual elapsed time because that will make no sense. Finally, the string.format method is used to format a string with placeholders that are replaced by specific values. In our case, the format string 0:00:1:00 contains two placeholders, which is 0 and 1. The values of minutes and seconds are passed in respectively to display the time in the minutes-seconds format. So I'll give you an example. If the stopwatch time variable is 75, which is basically 1 minute and 15 seconds, minutes would be 1 because obviously 75 divided by 60 equals to 1.25, which is rounded down to 1 via the mathf.floor_to_int method. And afterwards, the seconds will be 15 as that is the remainder of 75 divided by 60 as we just talked about with the modulus operator. And afterwards, the string.format method will then replace the 0 with 1 in the minutes place and the 1 with 15 in the seconds place. Let's now return to the Unity editor and create a text object under the canvas. Rename it to stopwatch display and customize its appearance as desired. I'll anchor mine to the top and align it to the center. Feel free to also disable both screens in the hierarchy to make it easier to work with. So you have to ensure that the stopwatch display is positioned above the screens in the hierarchy. This arrangement prevents it from appearing over the different screens. Next, set the time limit to 75, equivalent to 1 minute and 15 seconds, as we discussed in the earlier example. And before you hit play, assign the stopwatch display to the stopwatch display field on the Game Manager component. Now, when you play the game, you should see the time being displayed in the correct format. Furthermore, if you wait until the time limit is reached, the game should end as expected. Great! One last thing before we proceed to the next section. So as you may recall from the previous part, we already created the UI elements for the time survived. Now, let's link it together with the stopwatch by following these steps. First, let's create a new text variable called time survived display. And next, in the game over method, we can assign the time survived display.text with the value of the stopwatch display.text. So we place this assignment here because we only need to display the time that the player has survived without tracking it continuously. Now, return to the Unity editor and ensure that the time survived display field is properly assigned before starting play. During gameplay, once the time limit is reached, the time survived display object should showcase the duration that the player survived on the results screen. Great! Next up, we're going to tackle a really interesting part, which is the level up state. Now, you might remember that we've already built a system for our player to rack up experience and level up, but we missed one key feature, the level up state. So you can refer to this excerpt from the Vampire Survivors wiki. What this tells us is that upon leveling up, they enter a state when they can pick and choose from a set of upgrades which includes weapons and passive items. Thus, to implement this level up state, we first need to add several things to our game manager. Firstly, we'll introduce a new game state and call it level up. Next, we'll create a new public game object variable called level up screen. Afterwards, add a public bool called choosing upgrade and set it to false. This bool will just basically monitor if the player has entered the level up state and is in a position to choose among the upgrades. Lastly, ensure that the level up screen is added to the disable screens method to deactivate it at the start of the game. Now, let's add a case block for the level up state inside the update method. Within this case block, we need to check if the choosing upgrade is false, and if it is, we'll set it to true. This is similar to what we did in the game over case block. Additionally, as with the game over case block, we also want to pause the game when the player enters this state, so we'll set time.timescale to 0. And now, we will enable the level up screen. Finally, to indicate that the player has entered the state, we'll just use a debug.log to log in message. Now, let's create two new public methods called startLevelUp and endLevelUp. As their names imply, these methods will be used to enter and exit the level up state. Inside of the startLevelUp method, simply change the current state to GameState.LevelUp using the changeState method. This will transition the game to the level up state. Afterwards, in the endLevelUp method, set the choosing upgrade to false since the player has already made their choice. Then, resume the time by setting time.timescale back to 1 and disable the level up screen. Additionally, don't forget to switch the state back to GameState.Gameplay to resume normal gameplay. Next, in the player stat script, let's call the startLevelUp method within the levelUp tracker function. This will enable the player to enter the level up state when their level increases. Ensure that you place this line of code last within the function to maintain a proper flow of operations. Let's quickly test this functionality in the Unity editor. Create a new panel under Canvas, Screens, and name it Level Up Screen. So ensure that you place it above the other screens in the hierarchy, making it the first child of screens. What this will do is that it will just ensure that if the player somehow enters the level up state when the game is paused or has ended, the latter screens will still be displayed. Next, give the level up screen a grey tint similar to the pause screen, but just lower its alpha to a smaller value. Since we haven't implemented the upgrades yet and thus do not have the UI elements to end the level up state, we'll create a placeholder button under the level up screen called End Level Up State Test. You don't need to focus on making this button look nice because it's a temporary placeholder that we'll be removing later on. Lastly, to hook up this button, create an onClick event and assign it to addLevelUp method in the game manager. And now your UI should resemble something like this. Ensure that you've assigned the level up screen to its relevant field in the game manager component. And once all the necessary steps are completed, begin playing the game from the menu scene. And once you reach the required experience points, the game should transition to the level up state and the level up screen should appear, freezing the game. If you check the inspector, you will observe that the current state changes to level up. Additionally, if you check the console, you should also be able to see the debug.log line that we set up. With these three elements working together, our level up state is now fully functional. Now that we have the game state level up set up, we can move on to the more exciting part, which is creating the upgrade options for the player to choose from. So at first glance, this task may seem very straightforward because we have already developed the experience and leveling system for the player. And in addition to that, we have also implemented the functionality to add the weapons and passive items to the player's inventory, as well as leveling them up. So it kinda appears that presenting the upgrade options to the player shouldn't be that hard, right? Well, not necessarily. This process can be more challenging than it initially seems. Therefore, I highly advise you to stay focused during this section as it is very easy to make careless mistakes. With that in mind, let's begin working on the upgrades. So the first step, as with many of the complex features, is to establish a class structure, which is the prerequisite. In this case, we will set it up within the inventory manager script instead of the game manager script. This decision is based on the need for various references from the inventory instead of the game manager script, making it more logical to implement it within the inventory manager. Open the inventory manager script and let's start creating some nested classes to hold the data for the upgrades. So here are the classes that we need to create. First up, we need a class called weapon upgrade, which will hold the data related to a weapon upgrade. The next class we need is called passive item upgrade, which, as its name suggests, will hold the data related to a passive item upgrade. And last but not least, we need upgrade UI, which is a class that will hold the data related to a single upgrade option. Make sure to also add the system.serializable attribute to all the classes we just created. This attribute will allow us to view and modify the class instances in the inspector. Next, inside of the weapon upgrade class, let's create the following variables. First up, we need a public game object called initial weapon. This variable will be used to store the initial weapon or the prefab for the first level of the weapon, which will be helpful for later purposes. Afterwards, we just need a public weapon scriptable object weapon data, which, as its name suggests, will hold all the relevant data for the weapon, and will also make it easily accessible. We also create similar variables within the passive item upgrade class. Now, within the upgrade UI class, let's create the following variables. First up, we need two public tags named upgrade name display and upgrade description display. These variables will hold the references to the text objects and will be used to display the upgrade name and description respectively. Secondly, we need a public image named upgrade icon. This will hold a reference to an image object and will be used to display the icon for the upgrade. And third, we need a public button called upgrade button. This will just be a reference to the button object and will be used to handle interactions with the upgrade option. Now, let's create three lists to store the respective upgrade options for weapons, passive items, and the UI. Now, we can return to the Unity editor and inspect the inventory manager component. Let's create an element for each of the lists. and you should be able to see the various fields of the classes we created. Awesome! With this step, we have successfully established a proper class structure for the upgrade system, fulfilling the prerequisite for implementing them. Alright, now let's proceed to apply the upgrades, specifically by creating the upgrade options for the players to choose from. So if we consider the upgrades offered in Vampire Survivors, there are actually 4 types, which is new weapon, new passive item, upgrade for a weapon, and upgrade for a passive item. However, if you think really carefully, we can simplify this further into 2 options, which is just weapon and passive item. So why is this so? If you recall, when we first created the inventory manager, we actually linked the level up weapon method to the add weapon method, and similarly for the passive items as well. And if you're quick on the uptake, you may have already realized what I'm suggesting. Essentially, we only need to divide the options into 2 routes, which is the weapons and passive items. And once a route has been chosen, all we need to do is to just detect if the chosen weapon or passive item is new. And if it is, we can just add it as a new weapon or the passive item. However, if it's not new, we just simply need to upgrade it. And with that in mind, let's begin creating a new method called apply upgrade options. Inside of this method, we'll start with a for each loop that iterates through all the upgrade options in the upgrade UI options list. Within this for each loop, our first task is to determine the upgrade path, specifically whether it pertains to a weapon or a passive item. Now, to achieve this, we can actually utilize the random.range method. It's important to note that the random.range method takes in 2 integer parameters representing the minimum, which is inclusive, and maximum, which is exclusive values of the range. So, in our case, since we want to pick between 2 upgrade types, we should set the parameters to be 1 because it's inclusive, and 3 because it's exclusive. Next, let's proceed with applying the upgrade type. We'll begin first with the first upgrade type, which is the weapon. So if the upgrade type variable returns 1, which is a weapon, we need to choose a weapon upgrade. To accomplish this, let's create a local variable of type weapon upgrade called chosen weapon upgrade, and assign it to a random element from the weapon upgrade options list. Next, we need to add a safeguard in the form of an if statement to check if the chosen weapon upgrade is null. If it is not null, we can proceed with the rest of the method. Inside this if statement, let's create another local variable called new weapon and set it to false. This bool will help us determine whether the weapon chosen to be upgraded is a new one or an existing one. Next, we'll create a nested for loop within this for each loop. This loop will search for a weapon slot that matches the weapon upgrade to determine if it is a new weapon or an existing weapon. To achieve this, let's add an if statement within the for loop with the conditions that check if the current weapon slot is being iterated is not null. And if that slot's weapon data matches the weapon data of the chosen weapon upgrade. So if this condition is true, it indicates that the weapon is an existing one, meaning that the for loop found a match in the inventory. And then we can just set the new weapon bool to false because we already know that it exists. Afterwards, if the new weapon bool is false, it means that the weapon already exists, as I just said, and we need to level it up. In other words, this upgrade option presented to the player upon leveling up should allow them to upgrade this particular weapon when they click on the option. So how do we accomplish this? Well, we need to utilize a useful Unity method called addListener. addListener is a method in Unity's UI.button class that adds a new event listener to a button. When the button is clicked, all of its listeners are invoked in the order they were added. So in our case, we'll use the addListener to attach the level up weapon method to the upgrade options upgrade button using a lambda expression that specifies what should happen when the button is clicked. Make sure to pass in the index of the weapon slot. So once all of that is done, at the end of the if statement, add a break statement to exit this loop so that the next upgrade option can be applied. However, if the slot doesn't exist, which means that the weapon is new, we should set the new weapon bool to true. So if the new weapon bool is true, we can assign a listener to the upgrade button of the current upgrade option using the spawn weapon method in the player stat script. Ensure you pass in the initial weapon this time, as we are trying to spawn the initial weapon as the weapon is not in the inventory. So as we don't have a reference to the player stat script at the moment, let's create one. We will repeat this process for the passive item upgrade type. Now, let's assign the UI for the upgrade option. But first, we have to create some new fields in the weapon scriptable object and passive item scriptable object scripts. We need to create two fields, name for the weapon slash passive item name and description for the weapon slash passive item description, both of which are type of string. Back in the inventory manager, let's set the upgrade icon to the chosen weapon upgrade.weapondata.icon at the end. We don't need to set it based on whether the weapon is new or not, as the sprite of the weapon should remain the same regardless of its newness. However, for the upgrade description display and the upgrade name display, we need to apply them in two different scenarios. We need to handle the display based on whether the weapon is existing or new. If the weapon is existing, we should set the description and the name displays to the description and name of the next level's weapon. On the other hand, if the weapon is new, we can just assign the initial description and name of the level 1 weapon. So, to clarify, if the player receives a knife weapon, let's say, as one of the upgrade options, and they don't already have the knife weapon, the description will show something like, let's say, shoot knives, and the name will be knife. However, if the player already has the knife weapon, the description will showcase the benefits it gains when upgrading to the next level, such as maybe increased damage, and the name will be knife level 2, indicating the level of the weapon they will get when they level it up. Let's also do the same for the passive items. Before we proceed to test whether our system for generating and selecting upgrades works, we need to perform an important task, which is removing the upgrades and ending the level up state. Thankfully, this task is relatively simple compared to applying upgrades. First, let's create a method called remove upgrade options. Inside this method, add a for each loop to iterate through each upgrade option. Within the loop, use the remove all listeners method on each upgrade option to remove all listeners. This is very important as we need a clean slate for all upgrade buttons, lest we create errors. And now, to end the level up state, we just need to call the end level up method from the game manager script within the add weapon, add passive item, level up weapon, and level up passive item methods. By doing this, when one of the options is selected, the level up state will end and gameplay will resume. As you've probably realized by now, we also need a way to invoke the apply upgrade options and remove upgrade options method in order to get this system up and running. However, we face a challenge. How do we actually call these methods inside of the game manager's start level up method without directly referencing the inventory manager script? Well, fortunately, there's a simple solution. So instead of creating a code dependency on the inventory manager, we can reference the player's object instead and use that to invoke the methods. And how do we do that? Well, we're going to use a method called sendMessage. So sendMessage is a method in Unity's GameObject class that sends a message to a script component attached to the GameObject. The message can trigger a method or a function with a specific name defined in the script component. This means we can call the methods indirectly without explicitly referencing them. It's a very good get around. However, before we do so, let's create a method in the inventory manager called remove and apply upgrades, which will serve as a single method to invoke both the apply upgrade options and remove upgrade options. The reason for this is that sendMessage can be very intensive, so it's better to have a dedicated method to call these two methods instead of invoking sendMessage twice. Now, in the game manager script, we just need to create a reference to the player object and use sendMessage in the start level up method to invoke the parent method we just created. Great, now we have the functionality to apply and remove upgrades. Now, let's move on to the testing. In this section, we'll be testing the upgrade options, which requires several setup steps. First, let's create a UI for the upgrade options. In our game scene, navigate to Canvas, Screens, Level Up screen. We can remove the previously mentioned and Level Up state button as we no longer need it. Instead, let's add a text object called Level Up Text and anchor it to the top of the screen. Set its text to just, well, be level up. Next, download this UI assets pack from itch.io. You can find this in the link in the description. This pack provides 3 sprite sheets with a wide assortment of UI assets that you can use to enhance your game later on. But for now, we only need this sprite sheet. So import this UI sprite sheet into your project's art folder. Rename the sprite sheet to just be UI sprite sheet. Let's prepare the sprite sheet for slicing. Ensure that the sprite mode is set to multiple and the filter mode is set to point no filter. And of course, the pixels per unit is set to the sprite sheet's bit depth, which in this case is 32. Alright, so once the right settings are adjusted, open the sprite editor and proceed to cut out the border located on the top right of the sprite sheet. Once you are satisfied with the slicing, click apply to save the changes. Next, let's create 2 images and name them Upgrade Options Background and Upgrade Options Holder. Set their width and height to reasonable values, ensuring that both of them have the same size. Change the color of the Upgrade Options background to a blue tint. For the Upgrade Options holder, set the sprite to the border we sliced from the UI sprite sheet. Now, to ensure proper rendering, make sure that the Upgrade Options holder is positioned below the Upgrade Options background in the hierarchy. This will ensure that the holder appears above the background. Your UI should now resemble something similar to this. Before we proceed further, you might have noticed that the border looks a bit stretched, and when you resize the Upgrade Options holder, you'll notice a significant distortion. This is problematic because our game UI comes in various sizes and using a fixed size border won't work well for scalability. Normally, you would just have to modify the sprite asset in an image editing software such as Photoshop and just import it in again. However, there's actually a technique that we can use in Unity that can help us to overcome this issue. And the technique I'm referring to is called 9 slicing. For those of you who don't know, 9 slicing in Unity is a very powerful technique that is used for creating scalable UI elements such as buttons, panels, and other stuff. So, how do we apply 9 slicing? Well, it's actually quite simple. Open the sprite editor again and select the sprite cutout. You'll see green square dots on each of the lines. Move these green square dots inwards to create a new green square. Ensure that the green square encompasses the area where your content will appear within the sprite. This will create a border around the content that can be used universally. Once you're satisfied with the adjustments, click apply and return to the main editor. You should immediately notice the changes to the sprite. The corners of the sprite should now retain their scale and the border should now look much better. In case you don't see the changes, it's likely because the image type of your image component did not automatically switch to sliced. To resolve this, manually set the image type to sliced. Great, now we can continue with the next steps. So under the Upgrade Options holder, create an image object and name it Upgrade Option. Adjust its width and height to a suitable size and change the sprite color to a grey tint. And then under the Upgrade option, we'll create the following elements: an image object called Upgrade Icon Background, two text objects called Upgrade Description and Upgrade Name, and a button object called Upgrade Option Button. First, set the width and height of the Upgrade Icon background to something around 33 by 33 and position it accordingly, anchoring it to the left. Now change the color of the upgrade icon background to black. Create another image object as its child and name it upgrade icon border. Set its source image to the border sprite we prepared. The image type should not automatically be switched to slice, but if it doesn't, just change it. Next, adjust the pixels per unit multiplier on the image component to achieve the desired appearance of the border. Experiment with different values, but I found that around 5 works well in this case. Create another image object as a child of the upgrade icon background and name it upgrade icon. Set its width and height to 25 by 25. For testing purposes, let's also set the source image of the upgrade icon to the knife sprite. For the upgrade description and upgrade name, simply set their text values to match their respective names and position them accordingly. So regarding the upgrade option button, stretch it to cover the entire upgrade option. This ensures that the entire option area functions as the button, so when the player clicks anywhere within the option, it will select that particular option. Remove the text object under it. Afterwards, make sure that the upgrade option button is the last UI element in the upgrade option hierarchy, so it overlays all other child elements. Set its source image to the border sprite and adjust the pixels per unit multiplier to somewhere around 2.5. Now, duplicate this 3 times and rename them accordingly. To arrange the upgrade options vertically, add a vertical layout group component to the upgrade options holder. Configure these settings to make it look good. It looks good. With this done, you can also delete away the level up buttons we used for testing previously as they are no longer needed. Before moving on, let's also flip the upgrade description and upgrade name to fit the layout of Vampire Survivors. Before we proceed with testing, let's also assign the relevant fields and make some adjustments. First, let's add 4 elements to the Upgrade UI options list in the Inventory Manager component. Assign each of the upgrade options we created to these elements. Next, assign the weapon upgrade options and the passive item upgrade options list in the Inventory Manager component. Make sure to populate these lists with the appropriate weapon upgrade and passive item upgrade objects. Now, we need to assign the name and description for each weapon and passive item scriptable object. For the name, if the weapon/passive item is new, we should set it to the name of the item. However, if it's an existing item, set the name as the item's name followed by the level number. For the description, if the item is new, set it to a brief description of the weapon. However, if it's an existing item, set the description to indicate the upgrades the next level of the weapon will have. Lastly, for testing purposes, disable the spawning of second weapon test, in my case is garlic, and first passive item test, which in my case is wings, in the player stat script. With these assignments and adjustments, we are ready to proceed with testing. Begin playing from the menu scene and level up your character. You should now see the level up screen displaying the randomized upgrade options. As you can see, each upgrade option should have its own icon, name, and description assigned automatically, based on the randomized upgrade. Pay attention to the descriptions and names of the garlic and spinach, which should reflect their level 2 upgrades because they are already in the player's inventory. However, for the knife and wings, their names and descriptions should match their initial item. Select an upgrade option by clicking on it. The game should resume, and if you choose a new weapon, it should be added to your inventory. If you selected an existing item, it should be upgraded. Continue testing to ensure that everything is functional. Great job! Now that we have the general system set up for the upgrades and have confirmed that it works as intended, let's make some improvements. The first improvement we need to implement is the ability to upgrade a weapon or passive item beyond level 2. To demonstrate this problem, let's create a third upgraded variation for our garlic weapon. In the scriptable objects weapons garlic weapon folder, duplicate the garlic weapon level 2 scriptable object and name it to be garlic weapon level 3. Before proceeding further, let's also address an important issue that may have occurred if you followed my previous instructions very closely. You may have noticed that I've forgotten to assign the prefab fields correctly for the upgraded variations of the weapon scriptable objects. If you select the garlic weapon level 2 or the knife weapon level 2, you may notice that the prefab is still assigned to the level 1 prefab instead of the upgraded version that we created in the previous parts. Let's fix this by properly assigning the prefabs for garlic weapon level 2 and knife weapon level 2 scriptable objects to their respective upgraded versions. Back on track, navigate to the prefabs, weapons, controller, garlic weapon folder and duplicate the level 2 controller. Make sure to assign the correct weapon data to the duplicated controller prefab and repeat the same process for the non-controller prefab. Next, increase the damage value of the garlic weapon level 3 scriptable object to around 7 to reflect the upgraded level and make any other necessary adjustments to the details for level 3. Make sure to also assign the next level prefab field of the garlic weapon level 2 to be the garlic controller level 3. Alright, let's proceed with the testing. Begin by playing from the menu scene and start leveling up your character. Now when you level up, make sure to choose the garlic. Now continue playing and level up again. When you receive the option to upgrade the garlic, you will notice that the UI for the option shows the level 1, which is the initial garlic weapon, instead of the level 3 garlic. And if you select this option, you will realize that instead of upgrading the garlic to level 3, it simply just adds a new garlic weapon to your inventory as if you didn't already have one. So why is this problem occurring and why can't the weapon and passive items be upgraded past level 2? The issue lies in the apply upgrade options method where the code checks for an exact match between the chosen upgrade and the player's inventory. This approach prevents further upgrades beyond level 2 because the chosen upgrade always contains the data for level 1. As a result, the code treats higher level items as new and spawns additional instances instead of upgrading the existing ones. For example, if the player already has a garlic at level 2, the garlic's data in the player inventory will be for level 2. However, the garlic's data in the chosen upgrade option will still be for level 1, so you see the problem. Since the code only checks for exact matches, it will mistakenly treat the garlic level 1 as a new weapon even though the player already has the garlic at level 2 in their inventory. This means the code will spawn a new garlic instead of upgrading. To resolve this, we need to modify the apply upgrade options method to handle upgrades beyond level 2. Instead of comparing exact matches, we can update the chosen upgrade with the upgraded data after the weapon is upgraded. This way, the code will recognize the upgraded weapon in the player's inventory and allow for further upgrades. To implement this solution, we need to add an integer variable in the weapon upgrade and passive item upgrade classes. This variable will store the index of the upgrade data similar to the weapon index and passive item index variables in the player stat script. After making the necessary modifications, we also need to add an additional argument of type int called upgrade index to the level up weapon and level up passive item methods in the inventory manager script. Inside these methods, we need to assign the data of the upgraded weapon or passive item to the data of the corresponding upgrade option based on the upgrade index. This ensures that the chosen upgrade option receives the updated data after it is selected. Furthermore, in the apply upgrade options method within the inventory manager script, we also need to pass in the upgrade index when calling the level up weapon and level up passive item methods. Before starting the game in the editor, it's also important to assign the weapon upgrade index and passive item upgrade index values correctly. Ensure that the indexes assigned correspond to the element numbers in the list. The index for the first element should be 0, the index for the second element should be 1, and so on and so forth. Assigning indexes out of order or using incorrect indexes can lead to errors or unexpected behavior. For instance, if there's only one element in the list and you assign it as an index of 1 instead of 0, it will cause an error because the first element always has an index of 0. So it's crucial to maintain consistency and accuracy when assigning these indexes to avoid any issues during gameplay. Now, when you begin playing and upgrade the garlic, you should notice that the weapon data for the garlic upgrade option in the inspector has changed to match the level 2 data. As you level up again and receive the garlic option once more, you should see the UI displayed on the option now corresponds to level 3. And upon selecting the option, if you check the inspector, you should see that it correctly shows the garlic as level 3. However, we're not done yet, we still have an issue to address. If you level up the other options to level 2 such as the spinach passive item and receive their upgrade option, you'll encounter an error. So why does this error occur? Well, this error occurs because we're trying to access the next level prefab when it doesn't exist. So to fix this, we need to implement safeguards that prevents the code from continuing if there are no further levels beyond the current one, meaning the weapon or passive item has already reached the maximum level. This will prevent errors from occurring and ensure that the game functions smoothly. Great! Now when we upgrade a weapon or passive item to their maximum level, there will be no issues. The next improvement we'll be making is to remove the duplicate upgrade options. When playing the game and leveling up, it's common to encounter duplicate upgrade options. This is not ideal because we want a fair chance of being presented with all the available upgrade options instead of duplicates. To address this issue, we can use temporary lists to remove the duplicate upgrade options after they have been chosen. Let's start by creating two local lists. These lists will be copies of the weapon upgrade options and passive item upgrade options list respectively. We can achieve this by using the list constructor that takes in another list as its parameter. By creating these new lists, any modifications made to the available weapon upgrades and available passive item upgrades will not be affected by the original list, allowing us to manipulate the options separately and safely. When choosing an upgrade, we will modify the weapon upgrade options and passive item upgrade options list with the new list that we just created. And afterwards, all we want to do is just remove the specific chosen upgrade from the list once it's being selected. We can achieve this by using the remove method on the appropriate list. This ensures that the duplicate options are removed from the available upgrade options. Now, when testing in the editor, you should mostly receive all 4 different types of upgrades with no duplicates. However, there is a possibility of still encountering a duplicate option that can result in a out of range exception. This can occur when 3 or more of the available options are either weapons or passive items, which is a problem because, as you can recall, we only have 2 weapons and 2 passive items. In such cases, after the first 2 options are chosen, the list of available upgrades becomes empty, thus causing the error. To address this issue, we need to implement a check at the beginning of the function. If there are no available weapon upgrades or passive items, the function should just return immediately without making any further changes. If there are no available weapon upgrades, the script should set the upgrade type to 2, which represents the passive items. Similarly, if there are no passive item upgrades, the script should set the upgrade type to 1, representing the weapon upgrades. In cases where both the weapon and passive item upgrades are available, we just need to use the random arrange that we've been using to randomly select an upgrade type. By implementing these checks and adjustments that account for all situations, we can just ensure that the upgrade options are properly randomized and duplicates are avoided, providing a more balanced and diverse gameplay experience. The last improvement we'll be making is disabling the upgrade option UI when they are not needed. Let's perform a test scenario to understand why this is necessary. If you remove an upgrade option and then level up, you'll notice that despite there only being 3 upgrade options, the 4th one still shows up. To address this, we need to disable the UI elements of the upgrade options that are not in use. Inside of the inventory manager script, create 2 new methods called disable upgrade UI and enable upgrade UI, which both of which take in an argument of type upgrade UI called UI. In the disable upgrade UI method, we will retrieve the parent object of the upgrade name display element, which is the upgrade option itself, and then disable it. Similarly, in the enable upgrade UI method, we will retrieve the parent object and then enable it instead. After checking if the chosen weapon upgrade and chosen passive item upgrade are not null, we can call the enable upgrade UI method and pass in the upgrade option to enable the UI for the upgrade option. This will ensure that only the relevant upgrade options have their UI elements enabled. Furthermore, we can also call the disable upgrade UI method right after determining that a weapon or passive item in the inventory is at maximum level. By doing so, we can have an additional safeguard to ensure that the options for fully upgraded weapons or passive items are not displayed. Next, we can call the disable upgrade UI method inside of the remove upgrade options method. This will disable the UI elements for all the upgrade options before applying upgrades to them, ensuring that only the selected options are enabled. Now when you test the game in the editor with only 3 upgrades available, you will notice that only the 3 options are displayed when you level up. Furthermore, if you level up a weapon or passive item to its maximum level, it will no longer appear as an upgrade option. Awesome! You can now add back the 4th upgrade option once you have completed testing and are satisfied with the system. Before we end off this part, let's also create some additional UI that will help make the game much better. We'll first implement the player's health bar, which is long overdue. So in Vampire Survivors, the player's health bar is just represented by a red bar at the bottom of the player. To implement the player's health bar, we first need to create some UI objects for it. Inside of the game scene, under the player object, let's create a canvas that will follow the player's movement. This canvas will be used to display the health bar. Rename the canvas to be health bar canvas. Set the random mode of the canvas to world space, which will position the canvas in world space rather than screen space, which is very important. And then set the event camera to the main camera in the scene. And adjust the size of the canvas to scale relative to the player. For example, you can set the width and height to 5 and 1 respectively. Then position the canvas under the player object and align it correctly. Now, when you move the player, the canvas should also follow. Now, let's create the health bar. Create and rename an image to health bar. Adjust the width and height to fit inside the canvas. For example, setting it to 1 by 0.2 works well. Anchor the image to the top of the canvas. Now, to create the fill effect for the health bar, we'll use the image fill technique. First, set the source image to be a white square. If you don't have a suitable sprite, I found one and you can get it from the link in the description below. This sprite can be any form of white square, so you can just go into Photoshop and just do up a white square and then just export it. It doesn't really have to be anything special. This white square is very important because our next step is to set the image type to fill, and if you don't have a sprite set, you won't be able to change the image type, which is why we need to use a white square. Now, set the fill method to horizontal and the fill origin to left. This configuration will make the health bar fill from left to right. To complete the health bar's appearance, set the color of the image to red. This will give it a classic red color associated with health bars. Now, when you adjust the fill amount slider, you should see the health bar filling from left to right, just like a proper health bar. Now, let's move on to the code. Open up your player stat script, and we just have to do a few things in here. First, let's add the UI library as we'll be working with UI elements. Next, create a public image called health bar. And finally, create a new method called update health bar. Inside of the update health bar method, we'll need to update the fill of the health bar. We can achieve this by using the fill amount property of the image component. To update this fill amount, we'll calculate the ratio of the player's current health, which is just current health, to their maximum health, which is character data.maxHealth, and assign that value to the fill amount property. Now, we need to call this method in two places, inside of the take damage method and during start. Back in the editor, make sure to assign the health bar field before beginning play. Now, when your character takes damage, you should clearly see the health bar going down. Great. Now, let's implement the player's level display. In Vampire Survivors, it consists of two UI elements, an experience bar and a level text. First, let's set up the UI for them. Create a new image object under the canvas and name it experience bar holder. Anchor it to the top of the screen and stretch it to the full width using the top right anchor option. Now create two more image objects as children of the experience bar holder. Name them experience bar and experience bar border. Make sure that the experience bar is positioned above the experience bar border in the hierarchy. Expand these two images to the entire experience bar holder and then set the source image of the experience bar to be the white square sprite. Now change the image type of the experience bar to be filled. Set the fill method to horizontal and the fill origin to left just like we did with the health bar. And set the source image of the experience bar border to be the border sprite. Finally, create a new text object under the experience bar holder and rename it to level display. Then anchor it and align it to the right and center the text. You should have a similar end result to mine. Now onto the code. Inside of the player stat script, we need to start by creating two variables, which is exp bar and level text. Then create two methods, update exp bar and update level text. In the update exp bar method, set the fill amount property of the exp bar to represent the player's current experience level. To do this, divide the player's experience, which we need to cast the float, by experience cap. Casting experience to a float is very important because it ensures that the floating point division is performed, resulting in a decimal value that accurately represents the fill amount of the experience bar. If you do not do this, dividing them normally will use integer division, as both experience and experience cap are integers, which in turn will result in a truncated integer value, which is not what we want. As for the update level text, simply update the level text with level. Finally, all we have to do is call these methods. In the editor, assign the exp bar and level text variables to the corresponding UI elements. Additionally, let's modify the experience granted value on the blue gem prefab for testing purposes. Let's set it to around 30 for testing purposes. Now when you start the game, you should see the experience bar increasing as you collect the blue gems. And when you level up, the level display should update accordingly, showing the new level reached, and if there's any remaining experience after leveling up, it should carry over onto the next level. Excellent! Feel free to also revert the experience granted of the blue gem back to its original value once you have finished testing. That's all for this part. In this part, we went through how to create additional features for our game manager by continuing where we left off. We also covered some important additions to UI elements. I hope you all enjoyed the video, and if you want to support what we do, you can actually help us by becoming a Patreon. This will give you access to the project files for tutorials, like this one, as well as any Patreon exclusive posts on our blog. You can find the link to this in the description below. Any support that you give us will actually go a long way, because currently we are making back about 20 cents for every single dollar that we put into content creation. So your help will actually go a long way to help us make this a sustainable endeavor. So that's all. I'll see you all in the next part. Bye!